Hello students, this is your MGR. In this video, I am going to discuss try yourself MCQ questions from workbook 2 of solution chapter. Now let us start with the first question. Which of the following binary mixture will have same composition in liquid and vapor phase? Remember, same composition in liquid and vapor phase means which binary mixture forms azeotropes. Remember, azeotropes will have same composition in liquid and what? Vapor phase. So we know that only non-ideal solutions forms azeotropes, not ideal solutions. So remember, ideal solutions do not form azeotropes. So therefore, among the given options, so we have water and nitric acid and water and ethanol. They are the non-ideal solutions, whereas benzene and toluene, N-hexane and N-heptane, they are the ideal solutions. So option number B correct, because water nitric acid, water ethanol mixture are non-ideal solutions, hence they form azeotropes. Now we will move on to the second question. Which of the following statements are correct? Colligative properties are observed when? So it is obviously, so whenever a non-volatile solid is dissolved in volatile liquid, you can observe the colligative properties like elevation in boiling point, depression in freezing point, osmotic pressure, etc. So therefore, second question, option 1 is the correct answer. Question number 3. A 3-mol NaOH solution has density of 1.10 gram per ml. So remember, 3-mol NaOH. What is the meaning of 3-mol NaOH? So 3-mol NaOH solution means, remember, 3 mole of NaOH. 3 mole of NaOH dissolved in 1 kg of solvent. Dissolved in 1 kg of solvent. That is the meaning. 3 mole of NaOH in 1 kg of solvent. So now you can say number of moles of solute, N2. So solute here is NaOH. So number of moles of NaOH means number of moles of solute. So that will be 3 mole. Then how do you convert this into mass? So very simple, mass of solute WO2 is nothing but number of moles of NaOH, that is N2, into molar mass of NaOH. Molar mass of NaOH. So what are the number of moles of NaOH? So it is 3 mole, and you know that molar mass of NaOH is 40. Therefore you will get 120 gram. So that is a mass of solute. And of course, mass of solvent is given by the symbol WO1. So that is 1 kg of solvent. 1 kg means 1000 gram of solvent. So now you can calculate mass of solution. So mass of solution is nothing but mass of solvent, that is WO1 plus mass of solute WO2. So that will be 1000 plus 120. So that will be 1120 gram. That is a mass of solution. Now using this, you can calculate volume of solution. So volume of solution is nothing but mass of solution divided by density of solution. So what is the mass of solution? So 1120 gram. Density of solution they have given, it is 1.110 gram per ml. So if you simplify this, so you will get 1009 ml. So that is a volume of solution. So after knowing the volume of solution, so you can calculate the molarity of the solution. They are asking molarity. Capital M means molarity. So that is given by the formula mass of solute divided by molar mass of solute into 1000 divided by volume of solution in ml. So mass of solute is 120 gram. Molar mass of solute is NaOH, that is 40 gram into 1000 by volume of solution is 1009. So if you simplify this, you will get 2.97 molar. So this is the molarity of the solution. So in the question they have given molality 3 molal and they are asking to find out molarity. So therefore option 4 is the correct answer for question number 3. So now we will move on to question number 4. So you read that the normality of the solution of sodium hydroxide 100 ml of which contains 4 gram of NaOH is. So we have direct formula for normality. It is like molarity only. So normality is equal to mass of solute divided by, instead of molar mass, we have to consider equivalent mass of solute into 1000 divided by volume of solution in ml. So this is the formula. But how to find out equivalent mass? So remember, so I will calculate here. Equivalent mass is given by the formula for a base. Actually NaOH is a base, so molecular mass of that base divided by acidity. So what is the molecular mass of NaOH? If you calculate, molecular mass of NaOH will be 40. Acidity means how many OH minus ion, hydroxyl ion given by one molecule of NaOH. So NaOH gives 1 OH, that's why its acidity is 1. So equivalent mass will be 40. So now you substitute those values in the above equation. What is that? WO2 means weight of solute. Solute is NaOH here. In the problem itself they have given 4 gram, that is 4. Equivalent mass we have determined 40 into 1000 divided by volume of solution is given 100 ml. So by 100. So if you simplify this, you will get the answer as 1 normal. So option C correct. For question number 4, option C. Now we will move on to the question number 5. So you read this question. Concentrated H2SO4 has density 1.98 gram per ml and is 98% H2SO4 by weight. That means they have given mass percentage of sulfuric acid and they have given density and they are asking normality. So directly we have the formula normality is equal to mass percentage or weight percentage into density of the solution into 10 divided by equivalent mass of H2SO4. So mass percentage they have given how much? 98. So density is given 1.98 into 10. So what is the equivalent mass of H2SO4? Remember H2SO4 is an acid. So therefore equivalent mass of acid is given by the formula molecular mass of acid by basicity. So you recall in the previous class we have taken as molecular mass by acidity. Acidity is for base. For acids we have to take basicity. So what is basicity? Number of H plus ion given by the acid, one molecule of acid. So H2SO4 gives 2 H plus ion. That's why basicity of H2SO4 is 2. And molecular mass of H2SO4, if you calculate, you will get 98. So if you simplify, the equivalent mass will be 49. So you take that equivalent mass as 49. So if you simplify this, you will get 39.6 normal. So therefore, question number 5, option C is the correct answer. Now we will move on to question number 6. So read that question. Which of the following statement is correct statement? Correct statement, remember. You read one by one. Vapor pressure of solution of glucose higher than that of water. So it is wrong because glucose is a non-volatile solute. So when it is dissolved in water, so vapor pressure should decreases. So it is not higher than that of water. It is a wrong statement. But we have to select the correct statement, remember. Next, second one, boiling point of solution of 0.1 molal urea is higher than NaCl. So even that is also wrong statement. So because, so urea Van der factor will be, that means number of solute particles will be 1 because it is a non-electrolyte, it will not dissociate. But NaCl on dissociation gives 2 solute particles. So more the number of solute particles, more is the boiling point. So therefore boiling point should be more for NaCl, not for urea. So therefore even second option is wrong one. Now you read the third option. So third option is 0.09% solution of NaCl mass by volume is isotonic with what? Blood. So but the correct statement is it is not 0.09, it should be 0.9% solution of NaCl is isotonic with blood. But in option C they have given 0.09, that is also wrong statement. Is it clear? So all the three A, B, C are wrong statements. You read the last one. The freezing point of 0.01 molal solution of urea higher than that of 0.1 molal NaCl. So definitely NaCl Van der factor, that is number of solute particles will be 2, but urea I means Van der factor, that is number of solute particles will be 1. So more the solute, least is the freezing point. So for NaCl freezing point is least. So for urea, since number of solute particles are less, so boiling point will be freezing point will be more. So that's why urea has higher freezing point than NaCl. That is a correct statement. So sixth one, fourth option, correct one. Next, question number 7. Equal masses of solute are dissolved in equal amount of two solvents A and B. So respective molar masses have been given, Ma and Mb, and their relative lowering of vapor pressure of A is twice than that of B. Then how Ma and Mb are related? That is a question, 7th question. So remember, so they are talking about lowering of vapor pressure. Relative lowering of vapor pressure is there. So that's why. So what you can write the formula for RLVP. So generally relative lowering of vapor pressure is given by the formula mass of solute by mass of solvent into molecular mass of solvent by molecular mass of solute. So this is the general formula for RLVP. So now if you apply for the solution A, so RLVP of solution A so will be equal to, since equal amount mass will be same, that's why I will take W into molecular mass of A divided by molecular mass into WA. Similarly for B, RLVP of the solution B is again mass is same, therefore MB by molar mass into WB. So now you take the ratio RLVP of A divided by RLVP of B. So what happens? So WO and MM cancels out. So finally you can get what? WB into MA divided by WA into what? MB. Even equal amount, equal masses, therefore WB, WA cancels out. Finally you left with MA by what? MB. But RLVP of A twice that of B. So therefore this ratio will be 2. So 2 is equal to MA by MB. So therefore you can say MA will be equal to 2 times of MB. So this is a relation. MA is equal to 2 times of MB. So therefore option B correct. 7th question, option B. Now we will move on to question number 8. So you read that an addition of 1 mole of NaCl to 1 liter of water, the boiling point of water. So remember NaCl is a non-volatile solid, non-volatile substance. When non-volatile substance is dissolved in water, so definitely boiling point of water increases. So boiling point gets elevated. So option A correct. Eighth one, option A correct. Next question, which of the following has same value of Van Tuff factor as that of K3FeCN6? So remember K3FeCN6, so when it is dissolved in water, it dissociates into 3 times of K plus ion plus FeCN6 3 minus. It is a complex ion. So therefore, one molecule of K3FeCN6 will give totally 4 solute particles. 4 solute particles or 4 moles of solute particles. So therefore, Van Tuff factor will be 4 for this K3FeCN6. So in which of the following Van Tuff factor will be 4? So definitely it should be fourth option, because when fourth option, what is there? Aluminum nitrate. So when it dissociates, so you will get 1 aluminum ion, that is 1 mole of aluminum ion, plus 3 moles of nitrate ion. So totally here also you will get 4 moles of solute particles. So number of solute particles will be 4 moles. So therefore Van Tuff factor will be 4 in this case also. So therefore ninth one, option 4 is the correct answer. Coming to 10th question. So read that. Which of the following is an intensive property? Remember, intensive property means any property which is independent, on amount of the substance is called intensive property. So definitely it is option A, because vapor pressure of a solvent or a liquid depends on temperature, not on the amount of substance. So therefore it is independent of amount of substance. It is dependent only on the temperature. That's why 10th one, option A is the correct answer. Now you read the second question. Molecular weight of sodium chloride in 100% dissociated form in solution is determined by elevation in boiling point. Remember, so NaCl is an electrolyte. When it is dissociated, you will get 2 particles, 2 solute particles. That means number of solute particles, remember, number of solute particles, what happens? Doubles, increases by 2 times. Number of solute particles increase by how many times? 2 times. So that's why molecular mass of NaCl, so that is determined by measuring the elevation in boiling point, will be decreased by 2 times. Decreased by 2 times means it becomes half of the normal molar mass. So what is the normal molar mass of NaCl? 58.5. So therefore if you take half of that, it will be 29.25. So remember students, so why the molecular mass of NaCl determined by elevation in boiling point will be half of the normal boiling point? Because so NaCl is a electrolyte. So when it dissociates, the number of solute particles will be doubled. That's why molecular mass decreased by half times. So hence the 11th question, option B is the correct answer. Next we will move on to the question number 12. So you read that. Which of the following statement is true for separate equimolal dilute solution of urea and sodium chloride? So equimolal. So what is the meaning of equimolal? Say for example, I will take urea solution, because they are talking about urea solutions, and then one is, what is that, sodium chloride things. So I am going to take for sodium chloride also, sodium chloride solution. Equimolal. Equimolal means in urea solution, assume that the solute is urea and the solvent is water, of course. So number of moles of solute, let us take 1 mole, equimolal. So 1 mole. So number of moles of solvent. So you recall, molality is nothing but what? Molality means number of moles of solute in 1 kg of solvent. So 1 kg of water here. 1 kg means 1000 gram. If mass of water is 1000 gram, so what will be the molality of water? That is N1, solvent 55.55 mole. Similarly, for NaCl solution, NaCl is a solute. So that is also equimolal. That's why I will consider number of moles of NaCl as 1 mole. 1 mole in 1 kg of water. So 1 kg of water means again, so number of moles of solvent will also be 55 mole only. So obviously what happens? Mole fraction of urea, if you calculate, what is the mole fraction of urea? So N2 by N1 plus what? N2. So what is that? N2 is 1 mole. 1 mole divided by 1 plus 55.55. So even for mole fraction of NaCl also, you will get the same thing. What is that? 1 mole divided by 1 plus 55.55. That means mole fraction of urea and what? NaCl will be same. So that is a correct statement or true statements. So what is the answer for 12th one? So definitely the mole fraction of water are equal in two solutions. See, mole fraction of water means what? For example, mole fraction of water, if you calculate, so what is that? Number of moles of water, that is N1 by N1 plus N2. Number of moles is what? 55.5 by 1 plus 55.5. Even mole fraction of water in NaCl, same formula. What is that? Number of moles of water by total number of moles. So here also number of moles of water is 55.5 by total moles is 1 plus 55.5. So you will get the same answer. So mole fraction of water are equal in two solutions. That is the true statement. So 12th one, option C is the correct answer. Coming to the 13th question. So read 13th question. What is the effect of addition of sugar on boiling and freezing point? Obviously, sugar is a non-electrolyte substance plus non-volatile substance. Whenever a non-volatile substance is dissolved in liquid or a solvent, what happens? Boiling point of that solvent increases. Similarly, freezing point decreases. Elevation in boiling point, depression in freezing point. So therefore, for 13th question also, option C, boiling point increases, freezing point decreases. Now we'll move on to the next question. Question number 14. Read that. Which of the following statement is incorrect? Remember, osmotic pressure of 0.01 molar solution of barium chloride, KCl, acetic acid, sucrose. So definitely the order is correct because osmotic pressure directly proportional to the amount of solute, number of solute particles. So for barium chloride you will get 3 solute particles, 1 barium and 2 chlorine. KCl 2 solute particles, 1 potassium ion, another chloride ion. For acetic acid also you will get what? 2 particles because it is a weak electrolyte, acetic acid. So a little bit less when compared to KCl. But sucrose is a non-electrolyte. It will not dissociate. So therefore you have to consider 1 solute particles. So that is a correct order. Osmotic pressure so will be correct order. But you have to identify the incorrect statement. So therefore you cannot take option A. Second option, osmotic pressure of solution is given by pi is equal to mRT. So m is molarity. Molarity is nothing but concentration. So therefore you can write the same equation like pi is equal to CRT. So that we have discussed in theory class. So this is also correct statement. But you have to identify incorrect, remember. Third one, Raoult's law states that vapor pressure of component over a solution proportional to its mole fraction, correct? So vapor pressure is directly proportional to mole fraction. So that is also correct. 2 sucrose solutions of same molality prepared in different solvents will have same freezing point. So definitely it is wrong because so depression in freezing point is given by the formula delta TF is equal to KF into molality. So even though molality is same, but KF value, that is molar elevation constant, will be different for different solvents. So KF value differ for different will be different for different solvents. So that's why freezing point cannot be same. So if solvents are different, so therefore, so this is the, but they have given here same freezing point they have given, but we cannot have same freezing point. Therefore, option 4 is the incorrect statement, and that is the answer, correct answer for 14th question. Now we will go to question number 15. Question number 15. So what is that? Question number 15, you read. A solution of urea molecular mass is given, boils at 100.18 degrees Celsius at the atmospheric pressure, and Kf and Kb for water are given respectively. This solution will freeze at temperature. So we know that for example, for boiling point things, so molality is given by the formula. What is that? Delta Tb by Kb. Similarly, with respect to freezing point, so delta Tf by what? Kf. So now you compare these two equations. Since LHS are equal, you can equate what? RHS. Is it clear? So therefore what you can write? So delta Tf by Kf is equal to delta Tb by what? Kb. So if you want to calculate delta Tb, so delta Tb is equal to delta F Tf. So delta Tf is equal to delta Tb divided by Kb into Kf. So what is delta Tb they have given? Solution of urea boils at 100.18 degrees Celsius. So they have given, correct? So you substitute that. Delta Tb is given as 0.18 because it is water is a solvent. So urea solution boiling point, that is Tb. Water boiling point will be what? 100 degrees Celsius. So you take Tb, this is T0 B. Boiling point of water is T0 B, 100 degree. Boiling point of solution is 100.18 degree Celsius. Therefore, you take the difference, you will get delta Tb. So delta Tb will be 100.18 minus 100 degree. So it will be 0.18 degrees Celsius. So that I am writing here, 0.18 into Kf value is given. What is the Kf value? 1.86. Kb value is 0.512. So if you calculate that, you will get depression in freezing point as how much? 0.654 degrees Celsius. So now you can use the formula delta Tf is equal to T0 F, that is freezing point of pure solvent minus freezing point of solution. So we want freezing point of solution Tf. So Tf is equal to T0 F minus Tf. T0 F means freezing point of water. Freezing point of water is 0 degrees Celsius minus Tf. Sorry, this is delta Tf. So delta Tf value is 0.654 degrees Celsius. Therefore, you will get minus 0.654 degrees Celsius. So this is the freezing point of solution, minus 0.654 degrees Celsius. So therefore option C is the correct answer. Question number 15, option C is the correct answer. So now we move on to the question number 16. So read that. Which of the following represents the behavior of ideal binary liquid solution? Ideal binary liquid solution. And remember, for ideal solution, so solution which obeys Raoult's law. So Raoult's law can be written as P total is equal to P naught B plus chi A into P naught A minus P naught B. So you can equate this equation to equation for straight line. So what is that? This can be C, this can be M, this can be X. So this equation is like y is equal to mx plus c. So therefore here you remember along y axis, so we have taken P total. Along x axis, this is P naught A minus PB. So slope of the graph is chi A and intercept is P naught B. So therefore the Raoult's law equation for ideal gas, ideal solution is resembling equation for straight line. So with y-intercept P naught B. So with y-intercept P naught B, and the line will be, graph will be a straight line. So therefore, it should be option B. So P total versus chi A graph. This will be the x. This will be the slope M. Okay. So P total versus chi A graph is a straight line with y-intercept is P naught B. Second option is the correct answer. Next question, question number 17, you read. Question number 17. So two solutions S1 and S2 are separated by semi-permeable membrane. So assume that this is semi-permeable membrane. So this is, say for example, solution S1, this is solution S2. Solution S1 has got greater vapor pressure. That means vapor pressure of this solution 1 is greater than solution 2. This is vapor pressure is less. So what happens? They're asking water flows from, that is the question. So definitely when vapor pressure is more, so when vapor pressure is more means, so obviously solvent will move from higher vapor pressure to what? Lower vapor pressure across semi-permeable membrane. So therefore solvent means water, water flows from S1 to S2. So option A is the correct answer. Coming to question number 18. 2-liter flask A and B are connected to each other by valve. So assume that we have a 2 flask like this. This is flask A, this is flask B, and we have a valve here, and flask A is filled with benzene. So benzene, remember that benzene liquid will have its vapor pressure, correct? So what happens? You remember students, vapor pressure depends only on temperature. So since temperature remains constant, see at 30 degrees Celsius, only one temperature is given, and also they have mentioned temperature is kept constant. So vapor pressure depends only on temperature. Since temperature remains constant, even when you open the valve, so vapor pressure of the liquid benzene will not change. So therefore option C is the correct answer. The vapor pressure remains unchanged. So option C is the correct answer. So next to question number 19, you read that. So a graph has been given. So select the correct statement. That is a question. So you see that option A, what is that? For solution 1, delta TB1 is equal to BA. Remember for solvent, so this is the boiling point of what? Solvent. That is A, point A. Then solution 1 means, you remember this B and this is T1. Is it clear? For solution 1, so definitely the difference, this difference will be the delta TB, elevation in boiling point. So whatever the line BA represents, definitely delta TB of solution 1. So option A is the correct one. So you check, others will not match. Is it clear? So for solution 1, the boiling point, elevation boiling point will be T1 minus what? T0. T1 minus T0, and that should be equal to BA. Understood? So option A is the correct one. Question number 20. You read that. Which of the following mixture shows this type of vapor pressure graph? So remember students, whatever dotted line is written here, so dotted line represents Raoult's law or ideal solution. So since the graph is above the dotted line, that means this shows what type of deviation? Positive deviation from Raoult's law. So this is the graph for non-ideal solution showing positive deviation. So now what you have to see, among the given option, so which pair of liquids shows positive deviation, that you have to check. So definitely it is chloroform and carbon disulfide combination will show positive deviation from Raoult's law. That's why this graph holds good for the second option. Question number 21, that is a numerical question. So you read that question. They have given acetic acid CH3COOH. So when it is dissolved in water, you will get CH3COO minus and H plus. So now you can find out Van 't Hoff factor for this. Since it is a dissociation, for dissociation process, Van 't Hoff factor and degree of dissociations are represented by this relation. Alpha is called degree of dissociation. Since number of particles obtained by dissociation will be 2, therefore n can be 2. So substitute here 2 minus 1. Alpha means 20% they have given. 20% means you will get 20 by 100, that is 0.2. So if you simplify this, I value will be 1.2. After knowing I value, you can write the formula delta TF is equal to I into KF into M. So I value 1.2. So KF value they have given 2 Kelvin into molality is 0.1. They have given because 3 gram dissolved in 500 gram of water. That also you can calculate. Molality is equal to WO2 by M2 into 1000 by WO1. So WO2 means weight of solute, that is 3 gram. Molar mass of acetic acid M2 60,000 divided by solvent mass is 500 gram. If you calculate, you will get molality as 0.1. So I have substituted that molality as 0.1 here. So you will get elevation in freezing, depression in freezing point as 0.24 Kelvin. So 0.24 is the answer for question number 21. Now I will move on to the question number 22. So you read this. So you can directly, first you can find out delta TF by the given data. So this given by T naught F, that is freezing point of solvent minus freezing point of solution. So solvent is water, so 0 degree Celsius minus of minus 6 degree Celsius they have given. So it becomes 6 degree Celsius, that is delta TF. So now you can use the formula. Molar mass is given by the formula I into WO2 by WO1 into KF into 1000 into delta TF. So this formula, molar mass, so for a given ethylene glycol molar mass is 62. Formula is given, using that you calculate. And Van 't Hoff factor, so Van 't Hoff factor you can take this as 1 because it is a non-electrolyte. So Van 't Hoff factor will be 1. And then substitute, we have to find out WO2. So mass of solvent they have given 4 kg. 4 kg means it is 4000 gram. KF value for water, it is given 1.86. 1000 into depression in freezing point 6. So if you simplify that, you will get WO2 as 800 gram. So answer for question number 22 is 800 gram. Coming to question number 23. So you read that. Find the Van 't Hoff factor for calcium chloride they are asking. So of course formula osmotic pressure thing is given. Pi is equal to I into C into RT. This is the formula. So we have to find out I Van 't Hoff factor. So pi by CRT. So osmotic pressure is given 0.738. C means concentration. It is given 0.012 molar into R value, gas constant 0.0821 into temperature. You have to convert 27 degrees Celsius into Kelvin. It becomes 300 Kelvin. If you simplify this, you will get I value as 2.5. So 2.5 is the answer for question number 23. Now coming to question number 24. So this is also direct formula is there to find out KF. KF is given by the formula gas constant into freezing point of solvent whole square by 1000 into latent heat of fusion. So of course R value in terms of calories, because calorie per gram is given. So in terms of calorie, R value is 2 calories, 273, because they have given the freezing point whole square by 1000 into latent heat of fusion is given, it is 80. if you simplify this, you will get Kf value as 1.86 Kelvin kg per mole. 1.86 is the answer for question number 24. Now coming to the last question, 25th question. You read that at 25 degrees Celsius, vapor pressure of water is given. Find the vapor pressure of solution. 6 gram urea, 100 gram water, everything is given. So you know that when urea is dissolved in water, so lowering of vapor pressure takes place. So what you can write here? So you can write the formula RLVP is equal to WO2 by WO1 into M1 by M2, correct? So you take WO2 is mass of solute given, WO1 mass of solvent, that is water, 100 gram, into molar mass of water M1, that is 18, M2 means molar mass of solute, that is urea. So then on the LHS side, RLVP is nothing but it is P01 minus P1 by P01. So is divided, you will get 1 minus P1 by P01 is equal to 0.018. So therefore you can get P1 by what? P01 is equal to 1 minus 0.018, that will be 0.982 you will get. So they are asking vapor pressure of solution P1. So 0.982 into P01. P01 means vapor pressure of pure water, that is pure solvent water. They have given as 24 millimeter of mercury. So if you multiply this, you will get 23.568 millimeter of mercury. So 23.568 is the answer for 25th question. So thank you, students.